Okay, we're looking at algebra functions, which over here you can see exactly what that entails. We're going to be looking at adding two functions, subtracting two functions, multiplying them, and dividing them. So this may look kind of weird. The way this is written, you may think it's a little redundant, but let me kind of walk you through it. What we're doing here is we're defining a new function, and the way it's done is by adding the component functions there, f and g. It may seem unnecessary. You could probably figure it out from the name over here, the name of the function, what exactly we're doing. But I mean, that's the way it is. We're defining it to be the sum of these two functions. So let's look at an example of addition here. We're being asked to find f plus g of x, and they gave us f of x, and they gave us g of x. So in order to find f plus g of x, it's as simple as adding those together. So I take my f, which is 3x squared plus 2, and I'm going to add that to my g, which is 5x squared plus 7x minus 1. Okay. A lot of times when you see this written, it'll be written in parentheses. In this case, you don't actually need parentheses. I'll go ahead and put them in there. For addition, you're never going to need to actually use these, but for things like subtraction, which we'll do below, it's actually kind of important to use your parentheses. But since there's nothing out in front of our parentheses to multiply by or to distribute, there's no exponents, there's no signs to worry about, we don't really need these parentheses. So we could have just as well written this without parentheses. I guess I can rewrite it without parentheses now. Okay. And then my last step is to combine like terms. And I've got a 3x squared and a 3x squared, and a 5x squared, which I can add to get 8x squared. I've got 7x, that's the only x term. So I carry that down. And then positive 2 and minus 1. So 2 minus 1 is 1. So the great thing here is when we simplified this, we've got a nice new function here. We've defined a new function f plus g of x. So we've done all the addition we need to do. Now this is just the name over here, f plus g, telling us what it is. It's the sum of these two functions. But we've got that sum, we've got it done. Now we treat this f plus g just as a name. It's not telling us to do anything else. So we can do things like evaluate this function at a particular x value. So here we're asked to evaluate this new function at -1. So what I like to do when I'm evaluating a function is I'll rewrite the function with no variable. I'm just going to leave a blank spot where there was a variable. So instead of 8x squared, I've got 8 blank spot squared. Okay. So instead of 7x, I just have 7 in these parentheses, etc. Might not seem like the most useful trick. This can be kind of useful for function composition, which we'll do in a little bit. So now I'm being asked to evaluate this -1, this at -1. I'm just plugging in my -1. Okay. So let's see, -1 squared is positive 1. So this is 8 times 1. Here, 7 times -1 is minus 7. So this is 8 minus 7 plus 1. So that is 8 minus 7 is 1 plus another 1 is 2. And so we've got f plus g. When we evaluate that at -1, we get 2. Okay, so we could also subtract our two functions. So we're finding a new function f minus g of x. Okay, so we've got our function f, which is 2x squared minus 3x plus 1. We've got our function g, which is 3x squared plus 2x plus 1. And now we're going to do just what it says. We're going to take f and subtract g from it. So there's my x. My f of x is 2x squared minus 3x plus 1. And I don't really need parentheses in front of this one, or around this one. I definitely need them here. When I'm subtracting g of x, I need to subtract that entire function. I'm going to subtract 3x squared plus 2x plus 1. You may be tempted to just do all these signs on the fly. Go ahead and change these signs. You could do that, but I've graded enough papers to know that that's a very common place for mistakes. So write out this step and then distribute it on the next line. I know it seems silly. Students always tell me, I make simple mistakes. I can't get my signs straight. This is how you do that. Write out those intermediate steps. So now I'm going to distribute my minus sign. In this case, since they're all positive, now they're all going to be negative. That's actually pretty straightforward. But taking that extra time to do this, it just makes you think about it a little bit longer, and there's less of a chance of you dropping a sign off. So let's say we've got like terms again. 2x squared minus 3x squared is a negative x squared. A negative 3x and a negative 2x is a negative 5x. And then a 1 minus 1 is nothing. So there we go. We've got our new function. F minus g of x is just this, negative x squared minus 5x. Okay. What else? We can multiply our functions. We can do f times g. So f times g. Sometimes this is written with a dot in here. I like to write it with a dot. Later on, we're going to do function composition that has a big open circle there. Don't get the two confused in your notes. So if you're going to do a dot, make sure it's a nice solid dot, not a circle. Anyway, f times g. We're going to take f, which is x minus 2, and we're going to multiply it by g. And you notice this time I use parentheses. That is because we've got to remember to FOIL this. Right, when I've got two functions being multiplied, I'm going to need to distribute each term to each term. So x times 2x squared. X times negative 3 is negative 3x. Negative 2 times 2x is negative 4x. And x times negative 3 is wait a second. I was not paying attention there. There we go. I need to get my last terms. First, outer, inner, last. So the last terms are negative 2 times negative 3 to get positive 6. 2x squared minus 7x plus 6 is our new function, f times g. You don't really need to write this. You don't need to keep on carrying this down. But I think it's a good practice to get into. Just thinking about what it is you've got. You've got a new function that's named f times g of x. That way you can do stuff like actually plug things into this formula. You can evaluate this function as long as you know that that's what this is. That this is the name of a new function that you could then plug things into. So we found a bunch of functions. Going back, I could tell you to say, find f minus g of 3. So in our case, we did f minus g right here. We could just plug in our 3 to our final formula. That way, rather than having to rework everything, we could just plug it in right there. All right, last up, the only thing we've got left is to divide. So I've got f of x, I'm going to be dividing it by g of x to find our new function, f divided by g. So it's going to be x minus 2 over 2x minus 3. So some things about this is a rational function. Hopefully you're familiar with rational functions. Otherwise, I'm pretty sure I've got some videos about those, and there's always Google. So some things to know about rational functions is to simplify. To simplify, you need to factor. You need to be able to factor those terms and then cancel common factors. Now, do I have anything I can factor here? I don't. So I'm already done. Later on, it's going to be real important to think about the domain. And if you recall, since we can't divide by 0, we have to make sure 2x minus 3 does not equal 0. So, I want to write that. 2x minus 3 cannot equal 0. We can solve that. I get 2x cannot equal 3, and then divide by 2 to get x cannot equal 3 over 2. So our original functions were fine. You know, I could plug in 3 over 2 right here. I could plug in 3 over 2 right here. But my new function, I cannot have x equal to 3 over 2. That would cause this to be dividing by 0. It would cause this to be dividing by 0. So an important thing to keep in mind, we'll look at that later. And of course, that's summarized up here. When you do division, make sure you take a look at that domain. You have to make sure that you're not dividing by 0. So you're not necessarily going to be asked that every time, but it's something you should think about when you look at a rational function. You should always be thinking about, okay, just a reminder to myself, I can't divide by 0 here. So that means I've got this restriction. Finally, I've got another one here, f divided by g, but this time I've got one that's going to simplify. So when I write this out, my f of x is x squared minus 5x plus 6, and g of x is x minus 3. Now, you can factor this however you like. Since this is not a video about factoring, I'm just going to do it very quickly. Let's see, this numerator factors into x minus 3 and x minus 2. You can check that, of course. Negative 3 times negative 2 gives us a positive 6. And if I was to do the outside and the inside terms of FOIL, I get negative 2x and negative 3x, which combine to negative 5x. So if what I just said doesn't make any sense, that's fine. Just do whatever method of factoring you're comfortable with. Because that's our step for simplifying rational functions. We need to factor and then cancel. So make sure you can factor. You know, if you're having trouble with factoring, you're not going to be able to do these problems. That's why it's so important in this class. We just keep on using it. And in the denominator, I still have x minus 3. Now, the joy of this problem is that since we're able to factor it, and since we had a common factor here, we have x minus 3 in both the numerator and denominator, we can cancel that from the numerator and the denominator. I don't know why I made those. So I canceled my x minus 3. I'm left with just the x minus 2. And since that was in the numerator and everything in the denominator canceled, we don't have anything left. But there's nothing to write in the denominator. We just write it like this. And there's our new function.